Welcome to EDU World Space.
Chapter 4, number 31, we've got a chair sitting on a floor that is not frictionless. We're pushing down on the chair at 40 newtons with an angle of 37 degrees with the horizontal. First up, we want to draw a free body diagram for the chair. So let's go ahead and do that. We're going to take care of the weight of the chair. That's going down. We're going to take care of the normal force on the chair going up. And we have a frictional force going back to the left, opposing that, at least the horizontal component of our push force. So that's just what the free body diagram looks like for part A. Now in part B, they want us to find the magnitude of the normal force acting on the chair. And so this is going to be a force acting in the y direction, so we're going to use Newton's second law and look at the net force in the y direction. That chair is not accelerating up or down, so the net force in the y direction is 0. So filling in the forces that we have acting in the y direction, normal force is positive because it's going up. The weight of the chair, mg, is going down, and we have a component of that 40 Newton force going in the negative y direction. So that's why I made it negative. Let's take a look at what those components actually look like. We've got one component of that push force going horizontally, and we have one component of that push force going down. So picking up the down arrow and completing our right triangle over here, let's draw a little bit bigger picture. We got that component, we've got that, and we've got that guy going down like that. So this is our original vector, 40. This angle is 37, and we are looking for the side opposite. This is our 40 Newton force, the component in the y direction. So let's see, we're looking for the side opposite on this triangle. We know the hypotenuse. Opposite over hypotenuse is the sine, so we take the sine of 37, that's equal to opposite 40 sub y divided by the hypotenuse, 40. So hypotenuse times the sine of the angle gives us the side opposite. So that's what we're looking for in our Newton's second law above. So 40 sine 30 gives us So we're going to put that into our Newton's second law equation above. So solving above for the normal force, we have the normal force is equal to mg plus 40 times the sine of 37. Plugging those into our calculator and remembering that m is 12 kilograms. So we have 12 times 9.8 plus 40 sine 37. We end up with a normal force equal to 141.7 newtons. That's bigger than mg because we're pushing down on the chair. If we're pushing down on the floor harder, the floor's got to push back up harder. So that ends up being the normal force there in newtons.